Hi, welcome to Chapter 11, Section 3, Lesson 3, on measures of variation. Now, this is the second part to this lesson, and it's going to cover outliers. Now, you need to make sure that you understand and have already watched Part 2, which had to do with measures of variation and finding quartiles. What you're going to need is your math book. We're going to pick up on page 831 and cover 831 through 832. I'm asking that you do have a pencil and a pen today, and also a sheet of notebook paper. You will need a full sheet of notebook paper because some of the problems require a lot of space to work some things out. Be sure to work out examples on your own, as you should, and then watch through the explanations afterwards. So we're going to go ahead and discuss what an outlier is. Now, we've already talked about outliers in class a little bit, but an outlier is a data value that is much greater or much less than the other values in the data set. That means it sort of just doesn't belong. It's out of place. So it's a number that's so much bigger or so much smaller than the rest of them. However, one thing to keep in mind here, that the book wants us to really use the information that says that if a data value, and by data value I mean a number that's in your data set. So if you've got one of those numbers that is more than 1.5 times the value of the inner quartile range beyond the quartiles, that's when they're considering it an outlier. So there'll be a kind of an example that we're going to be working on a little bit later in this lesson, and you're going to notice that it looks like an outlier, but because it's not 1.5 times bigger than the inner quartile range, that it doesn't fall in that category. All right. So let's look at example 2. Now, on this example here, it reads, the ages of candidates in an election are 23, 48, 49, 55, 57, 63, and 72. You need to name any outliers in the data. Now, to find the outliers in a data set, there's a lot of steps that you have to take. They're not difficult steps, but they are a lot of steps that you have to take. The first thing you have to do is find your inner quartile range, which was in part 1 of this lesson. So in order to find your inner quartile range, all right, you need to make sure that you do all that other stuff we did in that previous lesson. So we're going to go ahead and review and list those steps now. So steps. First thing we have to do is find our IQR, which once again is your interquartile range. So if you remember how to find your IQR, you need to take your data set and put them in order from least to greatest, which in this example they already did. Now you guys remember, you're going to have to copy all this information down, including the numbers and everything like that. Now I do realize, like, the steps that we're writing on the far right side, you'll have room for that over in your work zone area, but the following numbers that I'm writing and the work that we're about to do, you may need to do on a separate sheet of notebook paper neatly to get it to all fit in. So now that I've got my numbers in order, I'm going to go ahead and find my median, and that is smack dab in the middle, that's 55. Now I need to find my quartile 1 and quartile 3. Remember, our quartiles are basically the medians of, like, those halves. So quartile 1 is the median number of the first half of my numbers, and that happens to be 48. And quartile 3 is the median of the second half of my numbers, which happens to be 63. So it's very clear cut on this example. So now that I have found my quartiles, I'm going to find my inner quartile range, which means I have to subtract 63 minus 48, and I get 15. Now the second step we have to do is we have to multiply our inner quartile range by 1.5. This is part of the definition of what an outlier is. It has to be beyond the 1.5 times the inner quartile range. So we found in the first step our inner quartile range was 15, so I'm going to multiply 15 times the 1.5. Now the 1.5 came from the definition. That's the definition of an outlier. It's got to be 1.5 times greater than, or beyond, I should say, the IQR. So that's where that number is coming from. It did not come specifically from this problem. It's just a number that you have to remember to multiply the IQR by. So I went ahead and did that, and I got 22.5. Now our third step is we have to subtract step 2's answer, which is 22.5, from quartile 1. So that means you need to write quartile 1's number down first, which was 48, and then subtracted by 22.5. Now notice how I did this. I added a decimal and a 0. I did it in a separate color so you can notice it. because when you're adding and subtracting decimals, you must line up your decimal points. And since 48 did not show a decimal point, I went ahead and added it in there, especially since we were subtracting. So I ended up getting 25.5. Now, that 25.5 is going to be our lower end of the range for quartiles. This will make, or for our outliers. This will make sense in a minute once I do the fourth step. So keep the 25.5 in mind. Just keep it there. Now, step 4, you're going to add step 2's answer to quartile 3. Now, step 2, let's remember this one. Step 2 was where you took your IQR and multiplied it by that 1.5. So what you're doing now is you're going to take quartile 3 and add 22.5 to that. Notice that I added a decimal and a 0 there, and I got 85.5. So now I've done my 4 steps. So this is all the work that you're going to have to do just to find the outliers. And we're not even done yet, but this next part's kind of easy. So now we need to pay attention to the 2 numbers that I have circled here in yellow. We have 25.5 and 85.5. Now, the definition of an outlier said that an outlier would be a number that falls beyond these numbers. That means in order for something to be considered an outlier, it has to be smaller or less than 25.5, and it has to be greater than 85.5. That means in order for it to be an outlier, it cannot fall between these 2 numbers that I have circled. So now I went ahead, and here I'm writing more steps down for you to copy. Steps 3 and 4 are the limits. Okay, so 25.5 is our bottom limit, 85.5 is our top limit. Any data numbers beyond these limits, that means on the outside of those limits, are your outliers. So if you look at the set of numbers that I've written, that we wrote down at the beginning, I put the little yellow stars about where my limits would be found. So any number that falls in between my limits, so we're talking about numbers in between my limits would be right here, are not outliers. It's only numbers that are kind of sticking on the outside, which is why it's called an outlier. So look what number's on the outside. That number is the number 23. So in this example, 23 is my outlier number. It means that it's a lot less than where the rest of the numbers pretty much lie on this example. All right, so now you're going to go ahead and try the do this or the got this problem. Now, I am writing the steps again. Now, the steps that you see that are showing up on your screen have already been done. So don't panic the fact that you see all this writing on here yet, but just listen to my explanation first. So steps 1 through 4 are what you just wrote down on your page. I just went ahead and rewrote them here as a reminder that these are the things you're going to have to do to answer this question. So the question reads, the lengths in feet of various bridges are 88 feet, 251 feet, 275 feet, 354, and 1,121 feet. Name any outliers in the data set. Now you're going to need your piece of paper. This is required. I'm not saying optional. I want you on your piece of paper to set up your piece of paper the way I'm showing you here. So what I would like for you to do is go ahead and put B and then list your 5 numbers, 88, 251, 354, and 1,121. I then want you to go ahead and leave a couple lines for space, and then do step 1, step 2, step 3, step 4 like I did here. And I'm just doing this to get you guys to keep your work organized so you can see where you're working and what we're doing. Now step 1 is our inner quartile range. And then down at the bottom, you're going to go ahead and list outliers. So now I already started doing this problem. You can see where our median is. So what I want you guys to do is before you pause this video, I want you to just listen to the rest of my explanation here. You need to find your quartile 1, your quartile 3, and then you're going to subtract them to find your IQR, which is step 1. So go ahead and pause the video right now for you to sit there, for you to go ahead and find the final answer for this problem, which is to name any outliers that are in this data set. Now remember, it's possible to have more than one outlier, but it's also possible that you would not have an outlier as well. So here I found quartile 1. So in order to find your first quartile, you have to find the median of the first half of your number. So in the fact that since there's only 2 numbers there, I had to add them and divide it by 2. So I found my quartile 1 to be 169.5. Now I'm going to do the same thing to find quartile 3. Now I know my quartile 3 is going to fall right here between these 2 numbers. So in order to find that, I need to add my 354 plus my 1,121, and then remember to divide all that by 2. You will get another decimal for this example as well. So my quartile 3 I found to be 737.5. So now that I have my quartiles, I'm going to go ahead and proceed to step 1, which is to find my inner quartile range. So remember, to find that, you're going to take your quartile 3 number and you're going to subtract it by your quartile 1 number. Now remember to line up your decimal points. All right, I might be repeating myself because I had to pause and walk away, and I'm coming back, and hopefully I picked up where we left off. All right, so I think we left off with finding our inner quartile range. So we subtract Q3 minus Q1, so you can see the numbers that we have there, and we end up getting 568. So now step 2 says to take our 568, which is our IQR, and multiply by 1.5. So doing all my nifty multiplication work, I ended up getting 852.0. All right, step 3. Here's where it gets not tricky, but if you remember what step 3 says, it says take your answer from step 2, and then it says subtract step 2's answer from quartile 1, which means I have to write the quartile 1 number first and then subtract 852 from it. Now, look what happens. Okay, do you notice this? You have 169.5 minus 852. You can't really subtract 800 something from 100 something that you had to begin with. I mean, you can. You're going to end up getting a negative number. So this is just true yuck. So basically, it's not going to work. Now, we can subtract this, but that's in our next chapter. We can subtract this, and you're going to end up getting a negative number for this. So it's not going to work out in your favor, but here's what we get. So we get negative 682 and 5/10, which obviously is my my range. So we know that that's not going to, 88 is definitely not our outlier because that number falls way over on the other side of 88. All right, and let's do step 4. So step 4 says you're going to take quartile 3's number, which is 737 and 5/10, and add the 852, which we got from step 2, to it. And then you get 1,589.5. All right, you guys, here's what this means. So back to my little yellow pen here. So these are my ranges right here that I'm circling. So any numbers that fall between these 2 numbers are okay. They're not considered outliers. So let's see where they fall. Negative 682.5 is way over to the left of 88. 1,589.5 is to the right of 1,121. So in this example, I don't like this example because it is a tricky one, but the numbers don't lie. There is actually no outliers. So where it says outliers on this one, you would write none, because none of the numbers that are in that data set meet the definition of what an outlier is. Even when you're looking at it, you really think it's 1,121. So that's why it's always important to not go with what you think, but to go with exactly what the numbers prove. So this is a very widespread data set. So it's kind of a tricky one, but I'll be honest with you guys, I did this problem 4 times now because I kept getting things that didn't make sense. Like, this doesn't make sense to me, but it is the answer, and I double-checked with lots of other math teachers and the book, and they all agree it's none. So here we go with this one. All right, let's move on to our next one. So on this example here, what you're going to do is it reads, the table shows a set of scores on a science test in 2 different classrooms. You have classroom A and classroom B. You need to compare and contrast their measures of variation. All right, you guys, that's the key words right there, compare and contrast. Now, you've done a lot of comparing and contrasting in other classes, not a whole lot in math as far as comparing and contrasting, but we have been comparing a lot of things lately. So when you're comparing and you're contrasting, you're basically going to find things that are similar and find things that are different, and then we have to talk about them. We have to write them in complete sentences. So on this example here, so over in your work zone area, remember, before we can get started, you must order your numbers first. So if you look at the numbers for room A, we have to put those numbers in order first, and then the numbers that we have for room B, we need to put those numbers in order next. So when you're doing this, it's important that you're neat and you keep your information organized, because you're working basically two problems at the same time, and then you're comparing them. So if you notice here how they have this set up, and I'm going to show you an example of how I want you to set this up on your own paper, you'll notice that once you get your ranges and your medians and your Q3s and Q1s and IQRs, you're then going to compare each number for both sides. So to compare and contrast, here's what you're going to be doing. So you want to compare each measure. The measures that you have to find this time are basically everything we've done. You need to compare the range, compare the median, compare the first and third quartiles, and then compare the interquartile range. Good thing is that you don't have to sit there and worry about the outliers for this type of question. When you do find your answers, you need to make sure you write incomplete sentences, because this part is going to be required for you to do. Now, looking at this, let's go ahead and talk about this stuff. So room A, they went ahead and, put the numbers in order from least to greatest. It's not shown on this piece of paper here on this screen, but they went ahead and put them in order, and they found that the largest number was 100. So now you guys, we're focusing our attention over in this area right here. So they took the largest number, 100, subtracted it from the smallest number, which was 65, and they got 35. That's your range for room A. Then they found the same thing, the range for room B. So now we're looking over here. So you'll notice that both ranges are 35. There's your similar there. We're comparing them. Those are the ones that are going to be the same. Now I'm going to go ahead and take away my circles real quick. Now we're going to look at our median. So the median for room A, which is the number smack dab in the middle, was 80. The median for room B was 81. Now they went ahead and found the third quartile, 89.5 for room A, 90 for room B. Then you're doing the same thing with the first quartile, 69.5 compared to 69. And then you find your interquartile range. So you found 20 for the first room, 21 for room B. So now that you have all that information, this is the part where you have to write your sentences and compare and contrast, like basically what you found. So you're going to tell me something about the range for each room, the median for each room, the first and third quartiles, and the interquartile ranges for each room. So let's go ahead and look at this part right here that's boxed in. So the first thing they talked about, and they did it in order, range, since it's the first thing that you guys found. They said that the range in each classroom is 35 points. Then they moved on and talked about, they went ahead, since they were talking about ranges, they went ahead and skipped and talked about interquartile changes. They then said that even though the range is 35 points for both rooms, they said room B has an interquartile range of 21, where room A has an interquartile range of 20 points. So they compared the ranges first, then they compared the IQRs. And notice how they did that. They just said, hey, room B has 21, room A has 20. So then they talked about the quartiles. Now they were a little bit more general about the medians and the first and third quartiles. And that's the sentence over here that I'm underlining. So they basically said that there were slight differences in the medians as well as the third and first quartiles. Look at your slight differences. I'm going to circle them. So for the median, room A's median was 80, room B's is 81. It was kind of a slight difference. It was a difference of 1. I personally would have said room A has a median of 80, room B has a median of 81. But for the remainder of the ones, look how close those the quartiles were. They are off by half, by 5/10, 89.5 to 90, 69.5 compared to 69. So they are less than 1 number away, which is why they went ahead and said that there were slight differences. They were a slight difference. It was a very minute difference. You could have also said that the differences between the two, the quartiles between the two rooms was basically, 1/2 or 5/10 apart from each other. Now it's your turn to give this a try. So I want you to do this example on paper as shown below. Now I haven't shown you your piece of paper yet, but I want to review a couple things before you get started. So reminder. So what I want you guys to do is go ahead and get your piece of paper out. which you should already have out, and I want you to divide the two sides in half, all right? The left side we're going to label Antelope, and the other side we're going to label Augusta. So these are the names of two cities. One's in Montana, the other one is in Maine, and their temperatures for different months. So remember, what you have to do is you need to put your numbers in order from least to greatest first. And then once you do that, you're going to find the range, the median, the quartile 1, quartile 3, and interquartile range for both numbers. All right, so now that you've got this information here, okay, don't forget to do what you're supposed to do. I want you to go ahead and pause your video in a moment, so this way you can work this out, and then when you come back, you're going to compare your answers with mine. So make sure you find all the information that is being asked of you. So you're going to, once you find all the information, which is the range, median, quartiles 1 and 3 and interquartile range, I want you to go ahead and I didn't put it on here, but on the bottom of your piece of paper, you're going to go ahead and compare and contrast them in a complete sentence. All right, go ahead and pause now. All right, so at this point now, you should probably have your whole problem finished, so let's see what you did. So the first thing I did is I went ahead and put my numbers in order, and I'm kind of such a dork because I didn't realize they were already put in order for us, but hey, go with it. So in Antelope, Montana, I found that my range was 58, my median was 50, quartile 1 was 30, and the third quartile was 70, and my interquartile range was 40. So so now we did the same thing for Augusta, Maine, and once again, look at me crossing them out as I put them in order, and they already were. I found that my range was 47, my median was also 47, my first quartile was 32, my third quartile was 66, and my interquartile range is 34. So that's the information that you need to have there. So now we're just going to sort of write about it. There's not a whole lot of similarities here between the two, and you can see that there's some subtle differences, but not a whole lot. So I'm going to go to the next screen so I have more room to write on this one. So here's what I came up with. So I talked about the range in temperatures and then the interquartile ranges next. The range in temperatures in Antelope are greater with 58 degrees and only 47 with Augusta. So notice how each time I'm going to put the Antelope number first and then the Augusta number second, since that was the order that I did my work and the order they were presented. And then I went on to say the same with the IQRs with 40 and 34 respectively. Now, instead of me writing over and over again Antelope and Augusta, I could put the 40 and the 34 for the IQRs, and I put the word respectively, which means in the order in which we were already talking about them, meaning Antelope first, then Augusta. So moving on, I said that Antelope's median is a bit higher at 50 degrees compared to 47, and then the quartile 1s are close with quartile 3s a little bit more spread out when you're comparing the two. All right, so now I know your statement in your sentence really should not be exactly or identical to mine. Mine's actually different than what the book put out as well, but I just want you guys to get used to comparing the two and talking about each thing, like the range, the median, the quartiles, and the IQRs and everything like that. So it's important that when you are comparing, that you do talk about the two together, the first one and the second one, and hopefully on any that you have to compare in the future, they're a little bit closer together like that previous one where you can kind of clump some of your information together. All right. So now what you're going to do for me here is you're going to go ahead and complete question 1D. Now, if you remember number 1, for the first part of this lesson, you already did parts A, B, and C, and we've already gone over those in class. So now you're going to do part D, which is to identify the outliers in the data. So you have it all set up. You just need to go through and continue with the work. And then you're going to go ahead and do part 2. Now, you know you're not going to really have enough room to do this all on this sheet of paper, so that's why I put on here a little reminder to do it on your own paper for this example. Be sure to staple it in your work. And yes, I want you to do number 3. We talked about the differences between measures of center and measures of variation in the first 2 lessons that we've already talked about. So think about how they are different, and then jot down a little note there for question number 3. All right, you guys, that's it for today, and we'll see you back in class.